if I asked you to tell me the difference between mutually exclusive events and non-mutually exclusive events, you might answer, my God, that sounds dull. Can we not talk about Dua Lipa's Radical Optimism tour? I'd love to. Let's save that for a future video, because in professional betting, we need to understand the difference between these two concepts for probability theory, and that's all professional betting often is. It's probability theory, statistics. It's making the mathematics work in your favor. If you've got a background, if you've studied probability theory, it might be intuitive, but if you haven't, you will often confuse these two concepts, and actually we get a lot of feedback where the person is confused, and the reason they are confused is they've mixed up mutually exclusive and non-mutually exclusive events. So let's break them down. Mutually exclusive events cannot happen simultaneously. Non-mutually exclusive events can happen simultaneously. Let's give an example. Goal scorer markets are very good for the differentiation between these. First goal scorer, either Fernandes or Rashford could get the first goal, but they both can't get the first goal. That market is mutually exclusive. And when we use an OR calculation in that market, we use the mutually exclusive OR calculation from probability theory. Anytime goal scorer is different. What is the probability of Rashford or Fernandes getting a goal in the game? Well, both of them could get a goal in the game. And so it's a non-mutually exclusive OR calculation, which is different, and we'll break down the mathematics in a little bit, but the exact example we're going to use in this video comes from a tweet from the head of strategy at Betdaq, Ender, who said back in September that there was value on Holly Doyle to get a winner at Brighton because the particular bet was trading at 1.92 on Betdaq betting exchange, and the fair odds were 1.8. And at Mad replied, how do you get to 1.8? If you take the composite of the lays on Betfair Exchange, which are 23, 3.75, 17, 11.5, 5.9, and 11, this would translate to an implied probability of 72% or 1.396. I'm curious if I've been getting these sorts of bets wrong all these years. And Ender actually replies, I use an excellent website called BookieBashNet. I will only give out rough prices if I give them out at all, as I don't want to be giving away their service for free. Maybe Tom Brownlee might be willing to discuss. Let's do it on this video. I'm going to move over to the drawing board where we can get a little bit into the mathematics. So these 6 horses had odds of 23, 3.75, 17, 11.5, 5.9, 11. That's decimal odds. And our question is, what is the probability that one or more of these horses will win at Brighton today? So the first thing we have to do is turn decimal odds into probability, because one, we're not heathens, and secondly, it's so much easier to use probability than it is to use decimal odds. So to do this, we take 1 divided by 23, and that equals 4.3%. And if we run down and do that for all of the odds, we get 26.9, 5.9, 8.7, 17.0, and 9.1. So all of these are the percents of the different horses that Holly Doyle has today. The wrong way to do this is to then add all of these up, which will give us 71.65%. And if we take the reciprocal, again, 1 divided by 0.716, that will give us decimal odds of 1.396. And this is the mistake that the person that replied to Ender's tweet made, because you cannot simply add up all of these events together to get 1.396. They are mutually exclusive events, and it's the wrong OR in probability. We can do a logic check of this, actually. So let's just imagine for 1 second that Holly Doyle's rides are 2.0, 2.0, and 2.0. She's got 3 rides today, and in all of those rides, she has evens. What is the probability that she gets at least one winner? Well, using this methodology, we get 50%, 50%, and 50%. And if we sum all of these together, we get, well, 150%. So this methodology of adding them all together, we're saying that there's over a 100% chance of her getting a winner out of those 3 races. Obviously, there is not. So what are we doing wrong? We're using the mutually exclusive OR calculation. What is the mutually exclusive OR calculation? Adding everything together. Let's get a new page. So a mutually exclusive OR, where only one event can happen, we add both together. The probability of A plus the probability of B gives us our probability. But the non-mutually exclusive OR, this actually overcounts. And if we have 2 events, the probability of A gets added to the probability of B, and we have to now take off the probability of A times B, of both events happening at the same time. Now that's our non-mutually exclusive OR calculation with 2 events. What about with 3 events? Well, with 3 events, we have the same thing. We add A to B to C, and we have the same issue where we've now overcounted, so we have to subtract the probability of the doubles coming in, which is AB and AC and BC. But now, unbelievably, we're still not right because we haven't considered the treble, which needs to get added back on. So we need to add on A, B, and C. So there's a lot going on with only 3 events. What if we expand it to 4? Well, with 4, same theory, with the probability of A and the probability of B and C and D getting added together. And from this, we now have to subtract the doubles, which are AB and AC and AD and BC and BD and CD. But now we've got to consider the trebles, so we'll add back on ABC, ABD, ACD, and BCD. And finally, we will take off the quadruple of A, B, C, D. And what we can see is that going from just 2 events, which is relatively straightforward, to 4 events here has got, pretty wild in not a long period of time. So I'm not going to write out the full equation for 6, but what it will tell us is that if we use this methodology, we get our 1.39, and the non-mutually exclusive OR calculation for 6 gives us 1.8. Any which way we look at it, the 1.9, we're getting a BETDAQ, especially if they're offering a concession commission rate in that particular market, is a fantastic plus EV value bet.